Okay, hello. We will solve the exercise 3, page 99. We will read it. Here we have a diagram, and then we'll try to solve the exercise. A baseball is thrown at an angle of 25 degrees relative to the ground at a speed of 23 meters per second. If the ball was caught 42 meters from the thrower, we have two questions. How long was in the air? And the second question is, how high above the thrower did the ball travel? Or you can see we have a diagram where we have a different positions in a baseball game. But basically our objective is, according to the situation, is that we have a ball in any position, it doesn't matter. But someone, imagine that, for example, this player has a ball here. Here we have the ball, and decide to throw this ball, okay, to this base. Sorry. Decide to throw the ball here. Okay. And can be in any other place, it doesn't matter. But the situation with this is that you know what is the distance. Okay, so the distance from this position until this position. Here we have 42 meters. Okay, so I know that here we have 42 meters. And I know the velocity or speed, in this case, that is 23 meters per second. And about this situation, so I know that with the horizontal, we have an angle of, the angle that we have here is 25 degrees, okay? This is what we have in the exercise. Okay, about the two questions. So if the question is how long, it's asking for a time. It's asking for interval of a time. And the second question is how high, okay? So if we have how high, is because the exercise is asking for a vertical displacement. In this case, is the maximum vertical displacement, okay? This is what the exercise is asking for. Remember that it's really important that according to the question, you should identify which is the variable that the exercise is asking for. This part is really, really important. Why? Because according to this, you will identify the formula that is helpful to solve the exercise, okay? So with the diagram, if we try to represent the situation in a diagram, is basically that you have a projectile motion. Okay, we have a projectile motion. And in this projectile motion, I'll draw the same situation. Okay, here we have the angle. Okay, that is going in this direction. So I just need to know the interval of the time and the vertical displacement, okay? If you check the formulas that you have, page 97, you have projectile launch at an angle, okay? So you need to decide which is the formula that is helpful in this case, okay? So the formula that is helpful, we have two in where you have the vertical displacement, but the easiest for is find the first, that is interval of the time. Okay, so interval of the time, it's a fact that you can calculate with the formula of horizontal displacement, because you know what is the horizontal displacement. Okay, we will write horizontal displacement, that is equals to initial velocity multiplied by the cosine of the angle. All this between a parenthesis, because you need to multiply that. Remember that this is horizontal component, and then multiply by the interval of the time. Okay. I'll write here the given information. Remember that it's really important before to start with the exercise by your given information. I have horizontal displacement. Horizontal displacement is equals 42 meters. The angle or the direction that we have is equals to 25 degrees. Okay, and as a given information, we have an initial velocity as well. The initial velocity that we have, this is equals to 23 meters per second. Okay, and something important that we don't have in the exercise, but remember that the acceleration in y, that is an acceleration in a vertical displacement, is that gravity. And in this case, remember in projectile motion, so this one will be negative. So it's negative 9.8 or 9.81 meters per second to the second power. This is the given information that we have, okay? So with this formula that we have here, what do I have to do? I just need to solve for the time. I have a multiplication, so I just will move the variables that I have in the side of the time as a division. This is what we have to do. Okay, so horizontal displacement divide by initial velocity cosine of the angle. And with this simple step, you can calculate the interval of the time. That is the first question that we have in the exercise. 42 meters divided by 23 meters per second multiply by cosine of 25 degrees. And we have the answer for the first question, okay? If we calculate this, the answer is, okay, so the answer is 2 digits after a decimal point, 2.01 seconds. Okay, 2.01 seconds. And there we have the answer corresponding for the first question, that is interval of the time. So I know that how long was in the air, so 2.01 seconds before that the other player catch the ball, okay? In 40, the distance, the horizontal displacement is 42 meters. So now I need to know, okay, how high about the thrower did the ball travel, okay? So I need to know, according to the situation that I have, remember that you have an angle. So here, in this position, okay, we have the maximus vertical displacement, okay? Remember that this displacement that we have here is increasing and increasing, it's rising. According to the time, we have a highest point, and basically this is what the exercise is asking for, okay? So we have two formulas to calculate a vertical displacement, okay? So this is up to you, which is the formula that you will use to solve the exercise. So right now, I'll write here the formula, but I think that is the best option that we have. Is you have there the vertical displacement. If we analyze the exercise, remember formulas you have on page 97, projectile launch at an angle. Okay, so here we have a velocity, final velocity in a vertical displacement elevated to the second power is equals to initial velocity elevated to the second power multiplied by the sine of the angle elevated to the second power plus 2 times the acceleration in y multiplied by the vertical or the maximus vertical displacement, okay? So what is the variable that we're looking for? We're looking for the vertical displacement, okay? Remember that I told you that before to start with a specific formula, so you need to check of if you have all the variables, okay? So I don't have vertical displacement, but this is the variable that we're looking for, okay? Acceleration in y, yes, you know, remember that is a given information because it's a projectile motion, is acceleration of the gravity, you know the direction, okay? So you know the value in degrees, you have the initial velocity, and we have another variable, a final velocity and a vertical displacement, okay? Or the final vertical velocity, whatever. Okay, so in this case, we don't have it, but remember that the situation that I have is that we have a player that throw the ball with this velocity, but after 2.0 seconds, the other player, what happened with that was caught at 42 meters. So what happened with this velocity after 2.01 seconds? So this is 0. So how you can see now, we have an equation just with one variable that is a vertical maximum displacement. Okay, so let's solve for the variable that we are looking for. Substitute the given information, and then you will have the final answer corresponding to this question. Okay, so this final velocity is 0. So 0 is equal initial to the second power, the sine to the second power, plus 2 times the acceleration in y multiplied by the vertical displacement. So 0 minus this multiplication, and then we have just the terms corresponding to, or if we relate with the vertical displacement, they're multiplying. So now 2 times this acceleration in y, that is the gravity, you will move to the other side as a division. What do I have to do now? Just substitute. Okay, so the initial is 23. I'll write just the magnitude, no the measurement. Okay, so 23. 23 multiply, remember that this is to the second power, don't forget that. 23 to the second power, sine of the angle, sorry, the angle is 25 to the second power. Don't forget that you have a negative here, so keep the negative when you substitute. 2 times the gravity, that is negative 9.81. My advice is that you solve numerator first and you write the answer, then denominator, and then solve the division, okay? So if we solve this equation that you have here, 23 to the second power, sine to the second power. So the answer that we have 2 digits after a decimal point, this is 4.82 meters. I'll write here that this is a vertical maximum displacement, okay? So this is the answer corresponding to the second question, okay? Second question is how high above the thrower did the ball travel? Remember that you have an angle of 25, so this ball here, the distance from this position until this position is 4.81 or 82, I don't remember. 4.81 meters, okay? This is the situation that we have in the exercise. And now we'll reply the 2 questions that we have with this exercise 3. How long was in the air? 2.01 seconds. And then how high above the thrower did the ball travel? 4.82 meters. This is the answer corresponding with this exercise, okay? So Thanks for your attention.